Okay, so hi everyone, good morning and good afternoon. I believe I'm audible and visible, guys. So please confirm in the chat so that we can start with the session. Okay, guys. So, anyone who can tell me what we are going to discuss today? I believe I have already. Okay, so Kubernetes, fine. So yes, in this class, I'm going to talk about basically Kubernetes in detail, in depth, basically. In my last sessions, I was talking about a Docker. So hope all of you are able to understand that, and yeah, so even you will be able to implement it. So when we are going to build the entire like a CI/CD in our upcoming session, so most probably by tomorrow, or if not tomorrow, then next Saturday for sure, because. Before that, so I was thinking of even talking about a terraform, basically. So terraform, by which you will be able to bring an automation into this entire ops part. Yeah, so fine, let me share my screen and let's start talking about Kubernetes in a very first place. Session is enough for industry. You will be able to implement this in any kind of application on any scale. So yes. Plus I'm going to show you even a cloud part, so how we can try to combine this with the cloud part. So first, let's do it in a local system, and if you are able to do it in a local system, then cloud is just that plus one, that's it, right? Because even inside a cloud platform, you will be able to find out all the managed services. For example, if I'll talk about a Docker, so there is a ECR, ECS, which is available. If I'll talk about a Kubernetes, EK is available, AK is available, right? So yeah, I mean, like cloud will be even like a more easier, I would say, as compared to doing something in a local, as they are already providing you lots of managed services, which is going to bring down your effort in terms of doing a implementation, and again, like setting up each and everything. So maybe in like 3 to 4 hour max to max, I would say, you will be able to do end to end setup for any new project on any given cloud platform, majorly all three: AWS, Azure, and GCP. So, fine, everyone, let's start talking about Kubernetes. So, let me open up my Scribble link in a first place. And first of all, let's try to understand what is Kubernetes, why we are going to use it, what is the advantage I will be able to get, all sort of things. Then we can start writing some sort of a commands. So, Kubernetes is also called as K8s, basically. So, Kubernetes. Kubernetes or K8s. So there are eight, like a character in between K and S, you will be able to find out. So it's called as basically K8s as well. So people, I mean, like it's just a short form of Kubernetes. Now, the very first question is what is Kubernetes? Why we are going to use Kubernetes? Because in my previous session, so we have discussed about a Docker container, right? So where there was a lot of pre-built images which is available inside a Docker hub. So we were trying to pull those images, and then we were trying to run those images, we were trying to use those images in the way that our application wants, or else we were trying to create our own custom images by defining some sort of a base image, and then we were trying to deploy our own application in our own way. Plus we were trying to open up even a port, so that I will be able to establish a communication between my container and basically my host, which is my Windows machine in my case. So Docker is fine. We were able to understand that, we were able to create a multiple containers, and eventually in lot of projects, so even I end up using this Docker, basically Docker container. So where I used to showcase a multiple example, and we also know that what is the advantage of using a Docker. So technically it is removing system dependencies. So you are not supposed to do a different kind of a configuration in a Windows machine, or maybe in a Mac, or maybe in a Linux machine. So one configuration which is going to work everywhere, and this is where this Docker comes into picture. Now, so let's say there is a situation, right? So there is a situation in our cases. So for example, we have a Euron system, and inside a Euron, if you will go and check, so yes, we have a course offering along with that. So we have, again, just to give you a courses, just to offer you a courses. So we have front end, right? We have a back end, by the way. Then along with that, so we have a payment system as well. Along with that, so obviously we have a authentication system, so by which you can log in into a system, and then you will be able to access a different kind of a services as per the quota or as per the limits which has been given to you. Along with that, so we have lot of AI services as well, lot of different other services as well. So for example, in terms of big services, so we have a Euron lab, let's say. We have basically a Yuri AI chat, which is a chat GPT. We have Yuri AI gateway, so which is a API system in itself. One more thing, guys. K3, Kimi K3 is available inside your API gateway. So you can try to use it. Kimi K3 is getting a lot of popularity, and again, so it is almost equivalent to a Fable, like a model Fable 5 model, which was available. Plus, I believe my team has done, yes, yeah. So team has also released a Fable 5 inside this Claude. You can try to use it. And yesterday night, I believe Anthropic has released Opus 5. So till Opus 4.8, it's available. Mostly by Monday, I'm going to ask my team that, try to make even that available. So like Opus 4.8 is there, and Opus 5 will also be available. Plus Sonnet 5 is also available. So I'll just try to make it available over here. So yes, these are the best model which we have, like, released as per the market. So coming back to our discussion, so we have a multiple, different kind of a services over here. Resume we have Avni over here, Euron code over here. So likewise, we keep on increasing based on the demand, right? Based on the demand. Now, there can be a situation so where I can just try to create one single container, right? One single container, and then I can try to run all of these things in that container itself, right? In that container itself. So that's a situation number one, as per our Docker class discussion, that my front end is running, my back end is running, my Yuri chat is running, Yuri AI gateway is running, interview questions are running, Euron labs is running, and everything is running inside one single box. Yes, inside one single box. And if that box goes down, so the entire system will go down. You will not be able to log in. You will not be able to use any other services, basically. And again, that's situation number one. And again, there could be a situation so where basically we are trying to build our services, and let's say I'm getting lots of traffic in Yuri AI chat. So Yuri AI chat requires more resource, more compute, by the way, as compared to maybe a self-paced courses or maybe a live courses, because live courses happens on Zoom. So obviously there is no traffic coming on this particular platform, except, like, opening up the Zoom link. So obviously load is going on Zoom, but lots of traffic is coming on Yuri AI chat. Lots of people are trying to access Yuri AI gateway, and yeah. So these things, these particular like offerings require more and more resources as compared to any other things, right? As compared to maybe my caching, as compared to my authentication system that we have, and any other system that we have built over there. So again, if I'm trying to put everything inside one single box, which is a container, so I have to keep on scaling up one single container itself, right? So which is going to be an hectic job for me. So what if I can try to adopt an architecture? What if I can try to do some sort of a arrangement or do some sort of a setup, so where I can try to distribute each and everything. For example, let's say my course offering requires maybe one single container with a specific configuration. When I say specific configuration, it simply means that I'm talking about CPU and RAM, by the way, right? CPU and RAM. So, and then my Yuri AI chat requires some different configuration, my Yuri AI gateway requires a different configuration, my resume system requires, and everything I'm trying to configure it as per the uses, basically. And when consumption will be high, so obviously I'm trying to set up a scale as well, that okay, fine, so allocate more resources just for this particular services, and every service is trying to communicate as and when it is required along with the authentication system. So if I have to build that kind of a system, then what is a tool which is available to me, right? Means I'm talking about multiple containers now, multiple containers, right? Multiple containers, small or big, maybe like anything. But yeah, I'm talking about a multiple containers and its management. So maybe I'm talking about a 20, 30, or maybe hundreds of container, and I have to manage all of these container. So then again, that will be a completely like a hectic task for me. I have to go and I have to manage all those 100. So again, one we have seen, and likewise I have to manage hundreds, right? I have to keep everything up and running and individually. And then I have to establish even a communication in between. If something is going down, some container is going down, so I have to go and I have to maintain and manage manually. So this is a hectic one, right? So you will say that, okay, fine, so let's try to keep only one container, let's run everything inside one single container. And it's better to fix one container instead of fixing like a hundreds of container. But no, that's not a great idea, because your resource distribution is not going to work in that particular manner. And when I'm talking about a scale, so again, it is not going to give you a lot of support in that situation when we are talking about this kind of a heavy application. In case of a lightweighted application, I mean, like, it's completely fine. You can run hundreds of website or simple web pages inside one single container. That's going to be okay. But not where, things are basically a resource incentive intensive, sorry, not incentive, intensive, by the way. So this is where the idea of this Kubernetes comes into picture. And what it does, so it try to help you out in terms of creating a small, maybe a container, establishing some sort of a communication in between. So it says that I'm going to give you a master slave kind of architecture. So where there will be one master, and this master will be aware about basically all the other slaves or nodes that we have, which is eventually a system or laptop, you can say. And then with the help of one single centralized interface, you will be able to access, and you will be able to basically maintain and manage each and everything. And it's just going to be one time setup. It is not like you have to do a setup again and again and again. So if you are going to do it once, it can runs for year and year, and that too even on a scale it will be able to run, right? It will be able to run. So this is where the idea of Kubernetes comes into picture. So it says that okay, I need maybe a three container for a backend, because backend will be always heavy. So I need maybe two for authentication, I need maybe one for my caching, eventually a Redis, right? uh, I want a situation so where, let's say, if one is going to fail, it should automatically restart, right? It should automatically, it should not like, because you must have seen multiple times in a production system that if it is one single container, I just have to go and restart again and again. But yeah, so let's say it is going to restart automatically. Let's say I'm talking about a replica, that one thing should work in a three different containers. So let's say if one replica is down, it will automatically spin the third replica. Means if I have written replica is equal to 3, it will always maintain 3 replica. I'll show you even in the example, right? Practical example, I'm going to show you that I'm going to delete one replica, still it is going to spin automatically in a fraction of second third replica. If I'm going to give 10 replica, it will always maintain 10 replica automatically. So that is a situation, so where Kubernetes is going to help you out in terms of maintaining, managing an application on any scale. Make sense, guys? Yes. Yep. Yeah. So let's try to understand. I think some couple of people, I can see some sort of a question over here. So let me take some questions. Session, yeah, I think I have answered. Is there any tool which supports Kubernetes to monitor a cluster? I'll be talking about that. I'll be talking about that. So yes, all these tools are already available. It's not nothing new in the market. So obviously, like around that, lots of wrapper, lots of tool is already is been built. And again, if you are talking about a cloud platform, so they have already given you like unified UI interface, so just go and manage it from there itself, each and everything, right? I'm not able to view any books for a gate exam and CSC. No, we have not generated all the books, by the way. We are still like generating it, because to generate a books and to create those books, so we are burning lots of token, believe me. A hell lot of token we are burning. So if you're preparing for a gate, I'm not sure about it. Yeah. So now let's try to understand that what Kubernetes is going to do and what is a Kubernetes architecture, because that is important. And if you are able to understand Kubernetes architecture and set that in your mind, believe me, whatsoever I'm going to discuss, after this, you will be able to relate in a very easy manner. So when we talk about basically Kubernetes, so here in terms of Kubernetes, there are two things or two separate entities comes together, and which is going to help you out to do this kind of a configuration. One is called as control panel. So one is called as control panel, and the another one is called as basically a worker node. Now, these are the only two things which exist inside a Kubernetes architecture, and everything fits inside either a control panel or inside a worker node. So, either you will be dealing with the control panel or you will be dealing with basically a worker node. So, I have created a very amazing, diagram, so which is going to give you a very clear picture about a Kubernetes. So, let's try to use this particular diagram. And again, so there are some keyword which is missing inside this diagram, so I'll keep on writing those things. So let me import this diagram to explain you the architecture. Yeah, it's bit blur. Now it's fine. Okay. So inside Kubernetes architecture, like I told you, so there are two things which comes into picture. So one is what? So one is basically a control panel. As you can see, I'm marking it in a red, and which is called as master node. I told you master slave architecture, right? So basically this control panel is called as master node, which is going to maintain and manage, or which is going to help you out in terms of doing each and everything with respect to a Kubernetes. And then here we have a worker node. So we have, let's suppose, one machine, we have a another machine. Now, inside this, you will be able to find out a multiple things. For example, there is something called as API server. There is something called as etcd. There is something called as scheduler. There is something called as controller manager. And you are supposed to be aware about all of these components, that which component is going to do what, which component is going to help me out in what manner, basically. Plus, here you will be able to find out something called as kubelet, something called as kubeproxy over here, something called as pod, which is a small entity, one of the smallest entity which execute things actually. So you are supposed to be aware about all of these things. And then there is something called as kubectl, right? A CLI, which we are going to configure in our system as well. So whether you have a Windows, Mac, or like a Linux, we are going to configure this particular part, and you are supposed to be aware about that as well. Okay, so let's talk about all of these component one by one, one by one. So as per my control panel, you are able to see that there is something called as kubectl. So what is this kubectl? So obviously I'm going to, Kubernetes is a layer, right? Someone has written a code to create this entire things. So I have to access a Kubernetes in a very first place, a Kubernetes services which is going to execute, or which is going to run in my system. The way we were executing, or we were using a Docker, the way we try to use Python, by the way, or any programming languages or any framework. So first of all, we try to bring those library, and then we try to access it in a similar manner. So with the help of this kubectl command line, CLI command line interface, which you can install, and we are going to install it, you will be able to access this entire architecture. You will be able to access this entire things, which is going to help you out in terms of doing all those configuration. Now whenever you will try to access, so for example, I'm trying to use this command line interface, right, my CLI, and I'll try to access. So in a very very first place, I will have to encounter, or I will have to basically go through something called as API server, right? What is this API server? So API server is nothing but the entry point. So somewhere you have to enter into that service, by the way, right? For example, if you have to use maybe a pandas library, so what you do, you try to import first, right? So that you will be able to use all those features and methods and whatsoever functionalities are there inside a pandas library or any other libraries. Same goes for like a Docker. So in the similar manner, so whenever you will try to access a Kubernetes cluster or your Kubernetes system, first of all, you will have to encounter a API server. This is going to be the entry point for any one of you. So whenever you fire any command from here, it simply hits my API server. Any command means literally any command you are going to fire. So it is going to hit my API server. Its name is API server. It's a service, right? Piece of code, basically. So it is going to hit my API server. Okay, fine. Now, so whenever you are going to hit this API server, So it try to validate and it will try to process the request. Let's say I'm saying that, okay, try to run this particular service. So obviously this API server is going to do some sort of analysis, and then it will try to process your request. So maybe I'm trying to do maybe some sort of like a networking over there, means I'm trying to open up a port or something. Maybe I'm trying to set some sort of a configure some sort of a IP addresses, or maybe I'm trying to configure or install some sort of a services. So everything will go through my API server, as simple as that. Now, the second component you will be able to find out called as etcd. Now etcd is what? So etcd is nothing but it's a internal database. So see, Kubernetes is going to do a lot of tasks. So obviously Kubernetes has to remember that what is running here, what is running here, who is doing what kind of a job, who is dead, who is alive, what kind of a configuration you have set, what kind of a replica you have set, which port is open, which port is closed, which network is allowed, which network is not allowed. So obviously I need some storage, right? Storage just for Kubernetes cluster, the particular configuration that I'm going to do it. So basically this etcd, you can call it as a database, not for the application. So you can't go and store your application data. For example, I have a Python application, right, and there is a form or something. So it's not like it is going to store that data. No, whatsoever data is required to maintain and manage these services, whatsoever it has to, you want, like, server, or you want this master to remember, right, that this port is open, replica is equal to 3, basically in this port this is something which is running. So all of these things will be stored inside this particular place. So basically it's a key value based. For example, port open 8,000, right? Number of replica is equal to 357, whatsoever it is. So all of this detail it is going to store inside my etcd. It's called as database of a Kubernetes. So it is going to store basically a cluster configuration, a resource definition, whatsoever is running inside a particular node, what is the status of the deployment, which one is down, which one is up, like a configuration map. All of these things it is going to store it inside this one, so that your entire server can use it, and then your entire server can work on that. Then there is a third component you will be able to find out, which is called as scheduler, right? Scheduler. So obviously I'm talking about not just one single services over here. I'm talking about a bunch of services, and I have to manage it, right? I have to manage it, I have to maintain it, and physically I have to run it in some machine, because at the end of the day it requires, every process requires a resources, maybe CPU, maybe RAM, maybe storage, right? So here this is a work done by my scheduler. So it decides where to run a pod. I'll come to pod as well, right? So scheduler is something which is going to decide that, okay, there is a service XYG you are trying to execute, and it requires this much of CPU. It requires this much of RAM. These many number of nodes are available to me, right? So all of these things will be decided and will be executed by my scheduler at the end of the day. So scheduler is, you can say, kind of things, who a manager you can say, so who decides, okay, who is going to do what, and manager is already having an idea that, which employee is having what kind of a task. Like if you don't have any kind of a task, okay, fine, you can execute this particular task if you have a bandwidth and if you have that kind of a knowledge or whatsoever skill is required to complete that particular task. So this is where my scheduler comes into picture. Then the fourth component, and these are the only four component exist inside my master node. So here controller basically try to always compare, and as I have mentioned over here, so runs controller like node, replica, and endpoint etc. So here what contain controller actually do? So controller keep on doing a comparison, basically, that what is a state which is required and what is a current state. I'll give you one simple example. So let's say I said that every time you have to maintain 3 replica, right? Every time you have to maintain 3 replica, okay? So basically this controller will, so desired state is what? Desired state is my 3 replica, but let's say one is going down. So controller will keep on comparing that, okay, fine, so 3 is required, 2 is available. So now go to scheduler and now ask scheduler that, okay, fine, spin the new replica, because 3 is a desired state which has been mentioned inside the configuration file. So this is where this controller manager is going to come into picture. It's not just going to come control the replica, I would say, but again, a job controller, node controller, endpoint controller. So you will be able to find out different kind of a controller. So technically, it try to do a very simple task: desire versus the one which is the ongoing one, right? So what is the desire and what is my current state? I'll just compare these two things, and then based on that, I'm going to pass a decision that, okay, fine, this is the desired one, so you have to achieve that desired one, so that this Kubernetes cluster will keep on running in a healthy state as per the configuration which I have done in the beginning. Is it making sense, guys? The control panel part, the master node part. So what happens inside the master node, what control panel does? Make sense? Any doubt? Always remember, four component: API server, right, the entry point, basically; etcd, a database; scheduler decides who is going to do what task, kind of like a manager managing their employees; and controller, the desired state versus the current one, so that nothing should go wrong at any point of a time. Make sense? Control panel, if crashes, then what happens? See, if it is going to crash, the entire master node is going to crash. So if entire master node is going to crash, then obviously you have to spin the new one. Now, so let's try to talk about the worker node, the worker side of it. So worker node is what? Executor node, right? At the end of the day, the one who is going to, you know, run your application. So let's say I have my backend, lots of APIs are running. Let's say I have my front end, so I mean like lots of UI, hundreds and hundreds of pages are running. So all of these things will run somewhere. My AI application, let's say I have configured LLMs, so LLM will run somewhere. So that somewhere is basically a worker node. Now, inside this worker node, as it's been mentioned, so there is something called as kubelet, right? There is something called as kubelet you will be able to find out. There is something called as kube proxy you will be able to find out. And there is something called as container runtime. And then inside that pod you will be able to find out. So let's try to understand one by one. So what is the meaning of this kubelet? So and again, so kubelet runs on each and every node. Let's say I have 10 laptops, it is going to I have connected all the laptops basically, and then one laptop is managing all the other laptops. So in that case, in every laptop there will be a kubelet. Now what it does, by the way, so kubelet is going to be responsible, or it is going to always make sure that container described by a pod running in a correct manner or not. Now, what is pod? Next question, right? So, pod is nothing but a smallest unit, I would say. A pod is nothing but a smallest unit. So, where your actual application is going to execute itself at the end of the day. So, here I have mentioned that pod is what? A smallest deployable unit, one or more containers. So, there is a possibility that in one single system, laptop, your laptop, right? I can run one Docker container, I can run two Docker container, or I can run 200 Docker container. Last time we have done that. It's not like only one container was running in my system. So in my system, so 1020 container was running at a same point of a time. So that smallest unit, that smallest deployable unit, so which is like a, which could be one or which could be more. So it is possible that I have a Docker, I have a Docker container for front end, one for front end, one for back end, one for caching, one for databases, right? One for my AI services, all five. Now, all five I can run in one single machine, right? One worker node, or maybe I'll run two here, three here. Possible, right? So it depends upon my configuration. And that container, which is going to run on a lower label, that one unit of a container is basically called as what? It's called as basically a pod. And here the kubelets is going to maintain and manage it. As simple as that, right? So, and kubelet is going to report the status back to my controller, that okay, fine, so this is running, this is running, this is running. So this is where this kubelet comes into picture. Now there is something called as kube proxy. So what this kube proxy does, so we have to establish a communication, right? So we have to open up some sort of a port, because container is a machine in itself. So everything will be running here inside this particular machine. We have already seen that, and we have to open up the port so that external world will be able to access it. Or container to container. So let's say I have a database services. So obviously my backend would access it. So obviously my backend is running in one container, my database is running in another container. So obviously my backend will be must be able to access basically a container where my entire database is running. So obviously I have to open up some sort of a port. Let's say my front end must be accessible by my end user, right? So obviously I have to open up some sort of a port. So wherever this front end is running. So it's not like everything we are going to open up to the internet. No, there will be like internal communication and there will be external communication, right? So we can try to maintain and manage all of these things inside a Kubernetes with the help of this service called as kube proxy. Make sense? The meaning of kubelet, meaning of kube proxy and a pod. Yes, it happens and it exists everywhere, right? It like exists everywhere. Fine. Now, so this is a very simple architecture. A lot of like a buzzword you will be able to find out. So there is something called as pod. I think we know about it. There is something called as deployment. So it manages a replica set and rolling updates. So let's say, I have to update some of these versions. For example, Python version I have to update. Nginx I have to update. So again, with the help of this service, I will be able to use it. Service means a stable network endpoint to access the pod. I mean, like let's say on 8000 port number, this particular IP address, I will be able to access some service just like that. Node is nothing but your laptop, you can say. There is something called as namespace. So for example, if I have to create a dev environment, test environment, pre-prod environment and prod environment, so I can try to basically give a name to it, tag to it. That tag is called as namespace. That okay, fine, so this is basically my dev environment now. So it is going to create one box for that, a Kubernetes box for that. Then test, another box. Then like a pre-prod, another box, prod, another box. So this is where this namespace comes into picture. In a technical term, it's called as virtual cluster inside a cluster. One machine, right? Inside that. So virtually, I'm just trying to, I mean, like on a physical level, everything is running in one single system or in one single cluster. But just with the help of that name tag that we have given, namespace that we have given, so we are just trying to segregate it so that everything. If I have defined that, okay, fine, this is my development, so it is development, testing environment, a pre-prod or prod environment. Then there is something called as config map. So store non-sensitive configuration information. So whatsoever non-sensitive information that we have to save, so in that case we can try to save it. There is something called a secret, so store sensitive data, for example your keys and passwords. By the way, there is something called as ingress. So with the help of this ingress service, you will be able to maintain and manage external access. So these are the core term you will be able to find out inside a Kubernetes. So how it works? So again, how it works comes from this architecture which I have explained to you. So you use a CLI, try to enter into the server or cluster, by the way. So you use kubectl to send a request to the API server. API server validate and stores the desired state in etcd, which is a database, by the way. Scheduler assign the work to suitable node. So this is going to assign a work like a manager, right? Kubelet on the node ensure containers are running. So again, this is a guy, maybe a lead inside a manager, so who is going to maintain and manage all the employees and then report to the manager saying that okay, fine, everything is running as per the expectation, right? So kubelet on node ensures the container are running. Then control manager, this one, basically this guy. So control manager continuously watch the desired one, the one that you have configured versus the one which is actually happening inside the machine on a physical level. So this is the five state. If you are able to keep these things in a mind, maybe for next 1 hour, I believe you will be able to learn things in a better manner. Make sense, everyone? Questions? Anyone who is having any question on this, like a discussions that we have done? Flow is clear? Teach us slowly, it is too faster, please teach us slow. Try to join all those classes. I'm not teaching something out of random. So basically every class is connected. If you have missed something in a last class, you will not be able to understand something in the next class. Very, very simple, right? Please try to join classes, all the classes, because everything is connected. Even next class will be connected to this class and the previous one. So guys, speed is fine. Shall I slow down? I don't think that I have discussed anything. But yeah, I think you guys can tell me. It's fine. Okay, fine. We'll go with the majority. But yes, those who are not able to understand something, so see guys, every class is connected again. So we have started this entire ops discussion with Linux. Now in Docker we have used those command, while like talking about a github we have used those command. So everything is connected, everything is in a flow. Yeah, everything is in a flow. So if you are new, then you will face some issues, otherwise fine. Okay, so let's move ahead and let's try to do a setup. Yeah, let's try to do a setup. So my machine is a Windows machine. Last time I have already done a Docker setup. So Docker desktop we all have installed, I believe. Yes, all of us have a Docker desktop, guys. Yep. Okay. Open up that. So just try to open up your Docker desktop, and then you have to go inside a setting basically. So here you will be able to see on a top side right, you will be able to see this setting icon. Just go inside this setting icon, and then on your left hand side, so one, two, three, four, five, the fifth tab, you will be able to see a Kubernetes, this one, right? So by default, it will be disabled in this state, right? By default, it will be in this particular state. You just have to enable it. And then what you have to do, so you can try to opt for, and by default, it will be this one. So cube DM by default. What is the meaning of this cube DM, by the way? So here, with the help of cube DM, you will be able to create a single node cluster with cube DM. And there is something called as kind. So it is going to create a cluster containing one or more node with the kind. So obviously, node means what? A machine. My I have only one machine. Simply means that technically I have only one node. Yes, all of you have one laptop in local. So technically you have only one node available to all of us. So whatsoever we are going to do it in a local, we just have only one node. When we will be talking about same thing on AWS, right? While creating those CI/CD pipeline and everything, at that point of a time, obviously we can try to spin as many machines as possible. And when I'm going to use EKS, I just have to fill one box that I want 5, I want 10 with this configuration, and I will be able to spin it. I don't have to go and manage individually all of those EC2 instances. Everything will be managed by EKS service itself. So here you can try to select this one or this one. Anything is going to be fine. Like it's completely fine. Maybe virtually, let's say I have created like 7 or 8, doesn't matter at all. Now just try to click on this apply. Click on apply and save it. Yeah. So now starting control panel, it will take some time. Sometime it takes like 5 to 6 minutes at max. It is going to install, joining a worker nodes. So everything will be done by this managed services itself. You don't have to do anything. Control panel ready. Ready after 7 seconds. Fine. Installing a registry miner, installing a cloud provider. Okay. Do it, everyone. Fine. So it's up and running, started 11 seconds ago. So desktop cluster successfully started. This is what it is trying to say. So in my system, Kubernetes services is up and running. So this architecture that we have discussed looks like it is up and running. If you are able to get that particular state, success state, it simply means that it's up and running. It simply means that I must be having a control panel and I must be having a worker node, all of these things configured. For example, API server, etcd, scheduler, control manager. And I was able to see it even in a log information that, okay, fine. So these things are like, it is trying to restart or is trying to configure these things basically inside my system. So I'm assuming, as of now, I'm just assuming that these architecture is up and running inside my system. And that is the only thing that you have to do. Yes. So in my previous class, we have already installed a Docker desktop. I'm just going to use the same. Now, question over here is that things are up and running, but how I will be able to access it? Yes, guys, how I can access it? See, everything is up and running, but how I can access it? That's a question. Yes. So CLI, kubectl, terminal, fine. So I told you, and here I told you, right? So this is going to help you out in terms of accessing this entire architecture that we have. So do we have this kubectl inside our system? Yes. Do we have a kubectl? No, we don't have that. We haven't installed the last class, right? We were like, dealing with the Docker. So we don't have this kubectl. Okay, fine, not an issue. I'll just go and install it. So let's go and install it. So command is very, very simple. Just try to open up your PowerShell or your CLI, whatsoever you have, and then we can try to. In my system, I believe it must be like installed because I have done that when I was preparing the material, right? Those who are going to do it from the scratch, so obviously you have to install a WSL, so that you have to enable the virtualization if you are using a Windows machine. In case of Mac or Linux, it will work by default. So in my system, WSL must be up and running. Yes, it is up and running. Last time even I have used it, so let me like exit it. So all of these things are running. It simply means that even Docker is running. So Docker is also running, so let's clean it now. So if we have to enable a kubectl inside my Windows machine, so what you can do, you can execute this command: winget install kubernetes.kubectl, so that you all will be able to use it. There is other providers as well, right? So there is something called a Chocolatey provider. There is something called a Scoop provider. So with the help of a Scoop or with the help of Chocolatey, I will be able to even install it. So yes, just try to install it, guys. Everyone, quickly. Fine, done, everyone. So people are asking that is it same for Ubuntu? Is it going to be same? Who is a package? What is the package manager for Ubuntu? APT, right? So instead of winget, what you have to do, so maybe you have to like call basically apt. Let me give you that uh, command as well. So apt installation is done on Windows. Great. Apt install kubectl. Yes, that is going to work. Apt install kubectl. Just use sudo apt install kubectl. In a sudo mode, you will be able to install it. Simple, right? Okay, so let me execute that. So found an existing package already installed. Yes, in my system, it's already installed. What is E and this ID? So E is nothing but basically E always tells you that give me the exact one which I'm looking for. I mean, like if I have mentioned this, so just with this I can even try to mention the version, by the way. So basically, it is going to give me that exact version. And what is the meaning of ID? So ID is something called as ISBN number. So it is nothing but a package identifier. So again, inside a Kubernetes for kubectl, there will be lots of different kind of updates. So it is going to be the package identifier, by the way. So here the version which I have installed is equal to 1.36.3. Let's say if I'm going to say that no, just install 1.30 point something. So that is going to come from basically like E for me. Now, so here what we can do, so if everything is installed, let me clear this one and maybe we can try to test the installation. So here I can try to write ctl and then cluster hyphen info. So Kubernetes control panel is running at http localhost 53162. Core DNS is running at localhost 53162 API v1 namespace kube system service this. So yes, this is giving me a cluster information that where my control panel is running. And we have already discussed about the control panel and its four components. So one is the API server, one is basically etcd, one is a service, and one is basically a controller. So now there is another command. So now it's confirmed that Kubernetes is running and this is my cluster information. Now here, so let's say if I'm going to write cube ctl and then get nodes. So these are the nodes which it has prepared for me, by the way. It has prepared technically 7 node. The reason is very simple. 7 virtual node. I mean, like on a machine level, I just have only one machine, so 7 virtual node it has prepared. Because when I was trying to spin this one, so I have selected kind, and here I have selected 7. So that's the reason. So it is trying to select 7. At max 10, you can try to do it. So 10 virtual node is been created, right? And this is the name that it has given. So the very first node is desktop control panel, then the worker, you can consider that as a 1, then worker 2, 3, 4, 5, 6. So yes, one desktop control panel node I have, and then rest is a worker node. 6 is a worker node. If I'm going to spin only one, so inside that you will be able to find out control panel as well as you will be able to find out the worker. So just try to type kubectl cluster information and then kubectl gets node. Gets node is going to give you list of all the node which is available inside your system. Again, so if you would like to know more about these nodes, so there is a command which is extension of the same command called as o wide. Wide means like show me more information, not zero, it's a o wide. So show me more information about this entire you know nodes. So now here you will be able to see that this is the name, right? It's ready. Control panel, age, what is the version, what is the internal IP address. So this is the internal IP address it has given to all of these node, which is virtual node that it has created. And then the OS image is basically Debian Linux 12, which is running. This is my kernel version, which is running over there. So yeah, these are the information it is going to show it to you. Container ID is equals to this one. Fine. So just O wide, try to attach O wide. It is going to show you more information about the particular node or all the node that you have inside your system. Now, so here this is about a node. Node means what? So node means this one, this one, right? Now inside a node we have a pods, by the way. So we have a pods inside a particular node. So here what we can do, so we can try to check a pod. So kubectl and then we can try to say get pods and then name is equals to, let's say I'm saying desktop worker. So inside that gets pod and then hyphen and pods. No resource found in desktop worker namespace. Okay, fine. There is no resources available as of now. kubectl, maybe I'm not able to recall the command to list down the entire node. This should be the command, by the way. So let me check what is the exact command for this one. This is the command. So pod and cube system. So here we are able to see all the pods which is up and running for now. So here you will be able to see multiple things inside a pod. So basically we talked about a kube proxy. We talked about basically a cube controller manager desktop control panel. Then we talked about this controller panel. There is something called as kindnet. There is something called as etcd that we have discussed. There is something called as we have a core dns. So all of these things you will be able to find out. So now we have a six seven nodes. So one two three four five six seven. So we have seven cube proxies. In every node there will be a cube proxy, and as we have already discussed, so Q proxy is going to help you out in terms of networking, right? In terms of establishing the networking. So seven node and seven cube proxies we have. Then we have basically this seven again, the kind net, right? So seven pod, seven kind net. Then we have basically a control panel. So one control panel is up and running. The cube controller manager. We have basically this etcd is nothing but a database, as we have discussed, right? And then we have a queue scheduler. So we have a scheduler over here which is going to allocate our things to each and every one. So here you will be able to see all the services. So let me ping you this command, guys. So this is going to list down the entire cube system, so how your cube system is actually looks like, and what and alls are there inside this one. So this is what this cube system is going to give you. It is going to basically tells you the entire cube system. Fine. So now let me clear this one. So we are able to see all these things that we have discussed in theory. It's practically visible to me. Then we can try to write cubectl cunfig view. It is going to give you the complete configuration one. Complete configuration it is going to give it to you, that how this entire cluster has been created and what is the configuration which has been done for this particular cluster. Certificate authority you will be able to find out over here. Cloud provider wise, so it has installed some of these, like providers, so you will be able to see that. So basically it's a configuration file you will be able to find out with respect to your Kubernetes. Even you can go and access this file, by the way. So let's say I'm into a Windows machine, so I can go here. I have a user. I have basically school as a user, and dot cube dot, yeah. So dot cube is a folder, and inside that I will be able to check all the configuration. So even here physically I will be able to access those files, and I will be able to check that out. And again, so sometime we also try to modify it as per the requirements, right? As per the requirement we try to modify it. So this is your configuration file. This is my like a cube cache file which I have with me. So fine, now we are able to see the cube configuration. So let me show you, let me ping you this command, configuration file. Okay, now so configuration is done. That's completely okay. I have to do some sort of a practical. So I have to understand that if Kubernetes is available inside my machine, how I will be able to use that Kubernetes, whatsoever theoretically that we have discussed. So how we can try to implement all of these things. So let's start with this. Done, guys, everyone. So are we able to check the configuration? Yes, it's working. If it is working, then only you can do the next step, the practical one, right? Okay, so let me open up my VS Code, and I'll try to create a folder for my Kubernetes practical. So here D drive cube practical. So just open up your VS Code so that we can try to write all those YAML files for a configuration. Okay, so here we have a folder, right? Inside this folder, what I can do, so I can try to write a YAML file. So see, whatsoever you have to manage or maintain inside a Kubernetes, maybe like you have to run 10 services, 20 services, or maybe like hundreds of services, you have to configure YAML file. For example, in case of a Docker, so we were trying to configure Docker file or Docker compose. Docker file for individual Docker, Docker compose for a multiple, right? Multiple Docker. Now here, so the file is basically a YAML file, YAML, yet another markup language, right? That's a file that you have to create. You can try to give any name to this particular file, and then you will be able to, spin whatsoever you want. So let's do one thing. So we are already familiar with NGINX. So let's try to create a service inside a Kubernetes, managed by Kubernetes, I would say. So where I will be able to configure a NGINX, right? Fine. So here what I will do, new files, and then pod.yaml. So now this is the file that you have to create. Name can be anything, whatsoever name you would like to give it. Extension should be YAML, YAML at the end of the day. Now inside this, we can try to define that what we are trying to basically, do. So in a very first place, you have to define a API version. So API version, let's say I'm saying that like it's my V1 by the way. So I can give V1, V2, V3, whatsoever I want. Now kind is basically a pod. So I'm trying to, this is something that I'm trying to create. Metadata. So what data of data by the way? So metadata wise, you can try to write over here that what should be the name of the pod that you are going to create. So NGINX, I can give any name. NGINX is a pod which I'm going to create, and then maybe you can try to give a label. So labels is something, you know labels is something like, key value pair you can try to give. So app NGINX, fine. So this is something that you have to give it as a meta information, metadata. Again, this is under your control. Give whatsoever name that you want. And then after giving a meta information, so you have to manage and maintain at the end of the day Docker container, right? Inside the pod, there will be a Docker container. And technically, pod is a Docker container, you can say. So I have to spin those containers. So to spin those containers, I think we already know that how to, spin those containers in case of Docker. Let me show you in case of a Kubernetes. So here there is a tab called as specs, and inside that we try to define containers, containers. So inside that I'm going to define containers, and now I can give a container definition that what kind of a container I would like to run, right? It could be 1, 2, 4, 5, 8, 10, or maybe one YAML, one container. Even in this manner, we can try to move. So here I can try to give a name of the container. So name is equals to NGINX container. I've given, let's say. Then obviously if this is a container, inside that image is going to run, maybe a custom image created by you, or maybe a image that you are going to download from a Docker hub, right? Because at the end of the day, inside the container means it is going to run some sort of a images into it, right? So that it will be able to give you a power to execute any application inside it. So name can be anything, you can try to give as per your you know wish. Now here, image you can try to write carefully. So let's say if I would like to use some sort of a image from a Docker hub, so obviously that image must be available. Otherwise, I can try to give a local reference of my Docker file to create a image. That's also possible. So here nginx and then nginx 1.27 is a image name I have given. It If it is available in my local, it will pick it from there. If it is not available, it will go and search for a Docker hub. If it is not available on Docker hub, error. As simple as that. So image I have given, and then PORTS ports basically. So basically I can try to give basically here a container port, container container port over here, and let's say I have written container port is equals to 80. Okay, so container port. So this is going to be my smallest possible setup, so by which I will be able to use Kubernetes. Inside that, I will be able to run one small pod, right? So as per this diagram, I will be able to run one small pod. Inside this pod, my nginx service will be up and running, and maybe in a future, I mean like in next 10 minutes, we can try to expose it to my local, and from my local I will be able to access it. So now this is a pod, and this is how you can try to create a smallest possible one. Make sense, guys? Yes. Nginx, a pod. Pod means a smallest unit where services are actually going to run. So basically, I have created a small pod. So where my nginx service is going to run. It could be front end, it could be back end, it could be nginx, it could be my databases, it could be my Kafka services, it could be my Spark, anything I want. I can simply run it, right? I can simply run it. Now, how to run it? Yeah, how to run it? So let me ping you this one, guys, so that every one of you can use it. Okay. So this is basically a configuration, and now I'm going to use this particular configuration, a pod YAML configuration. Now, if I have to run this one, right? If I have to run this one, so what should be the approach to run this one? How I can run this one? What should be the approach? I think we all know the approach, right? To access anything inside my Kubernetes, what is the entry point? kubectl, as simple as that. So what I will do, I'll try to run this one. So maybe I can try to open up my terminal from here itself, and then inside that, it's already available. I can try to check whether kubectl is available or not. kubectl, it must be available. So yeah, it is available over here, right? It is not giving me any kind of a command helps more. Yeah, subcommand provided by plugins. Okay, so it's available to me. I can even come over here. So let's say I can copy a path and then cd this one. Now I'm into this drive ls. So basically this pod.yaml is available to me, so I can run it from here, I can run it from VS Code, doesn't matter at all. Anyhow, I will be able to run it. So here, if I have to run this particular one, right? So kubectl, and then I can try to write over here apply. So apply is a command. Forcefully, if you have to apply, you can then write f, otherwise leave it. And then you can write your file name. So pod.yaml, fine, pod.yaml. So pod nginx pod created. So nginx pod. Now here, nginx pod is created. This is the name that I've given. So yes, it has created the pod in my machine. Now, so if I have to get like idea about all the pods, so kubectl kubectl get pods. So which one is running? My nginx pod is running. Status is running, as you can see over here, right? Status is up and running. Detail output, again o wide. So o wide detail output. So my nginx pod is running at this IP address desktop, and it's running in what? It's running in worker 3. Now this worker 3 will be decided by whom? Who is going to decide? Who is going to be a decision maker that whether it should run on worker 1, 2, 3, 4, 5, 6? Because I have in total 6 worker node. Who will decide that? Okay, let me show you the architecture once again. Now tell me who is going to decide. Scheduler, right? Someone is saying control panel, control manager, someone is saying it's a scheduler. So technically it's written, right? That decides where to run. See, control managers only does one thing. I have decided, I'm going to show you in next couple of minutes, by the way. So let's say I have decided replica is equal to 3. Now one is down, right? Or maybe I have deleted it purposely. I'm going to delete it. I'll show you that command as well. So purposely I will be deleting it. So now it became 2. But as per my configuration, which I am going to write in my YAML, is going to be 3. So it will try to maintain that state 3. So there must be someone who can watch it, right? Who can keep on watching it. This is where this control manager comes into picture. Very, very simple. Don't tell me control panel. I mean, like, control panel is a combination of these four service: API, etcd, scheduler, and control manager. Hope it makes sense. Yes, fine, everyone. What does kubelet do, sir? Okay, this question's coming very late. What does kubelet does, guys? I must have mentioned here also somewhere. Yep. So basically, kubelet is a local to a particular node. For example, I have 6 node, right? So obviously, in every node there will be like a kubelet. What it does? So technically, it's a kind of a program, or you can say it's kind of an agent that runs on each and every worker node. Let's say I have like 6 worker nodes, so there will be like 6 kubelet, which will be like a running, and it is going to be a local supervisor. Every node, right? So I need some local supervisor, right, who can see you, who can check that, okay, now in which port what is running, what is not, so that whenever this control panel, this master will require some information, so someone should provide that information. This is where this kubelet comes into picture, a local manager to a particular node, for understanding purpose, and if you have to remember, right? Okay, fine, so let's move ahead, and my nginx pod is running, right? Nginx pod is basically like a, up and running. Now I can go and I can even inspect this nginx pod, which is my custom pod. So here, to inspect it, kubectl, and I can write describe command, just like in pandas we write describe, so it just give a description of the entire data set, simple like that. RIBDSC, RIB, describe what? To describe a pod. Which pod? So my nginx, whatsoever name that you have given, you have to give that. So this is a whole description detail of my nginx custom pod. It is going to give it to me. Namespace, by default, I have not attached any kind of a namespace like a development test or something like that. So default namespace it is going to take. Priority is 0. Service account default. Node is basically it's running in third worker node. Technically fourth, right? No, third. Yeah, third. The start time, this one label is this which I have given coming from my YAML file itself. So this label is coming from my this one, and then annotation, I have not given anything. Status is this, IP address is this one, which is running container ID. So obviously this entire pod is trying to run what? So trying to run some sort of a container. So this is my container ID. Image is basically nginx 1.27, which I have already defined. Image ID, so from Docker Hub, it is trying to download this particular images. Port number 80 TCP, which is open host port. Nothing is open so far. I'm going to open up in some time. So here you will be able to find out the complete history, civic geography of a particular pod. Make sense? The describe command. Kubectl describe pod and then pod name. Done. Then obviously if I'm running this pod, so there must be some sort of a logs. So kubectl, and then I can try to write logs logs what? In logs of what? My pod. So my pod name is nginx hyphen pod. Okay, so this is basically a log so far. It has like generated, and it is going to like tell you that okay, fine, so these are the log which is available. Fine, so you will be able to check a particular log as well. Now technically, a container I'm trying to run, right? This is the meaning, right? So here I have a pod. Technically it's a Docker container. Agree or disagree? Yes, agree. Technically I'm trying to run basically a container, and with the help of Kubernetes I'm just trying to manage it, right? As of now there is only one, but yeah, I mean, like, Kubernetes has been basically designed to manage multiples. So I wanted to get into that pod, I mean, like, I wanted to get into that system, and I wanted to execute some Linux command manually. What was the command in case of Docker? I believe in case of Docker we have done that. What is the command in Docker to get into a container and access the CLI of that particular container? Exec, right? Execute command. So even here we have a execute command. So here everything you are trying to control via, I mean, like, your entry point is basically kubectl. So kubectl, just write it down instead of Docker. So last time you were writing like a Docker, and yes, I'm very happy that many people are able to remember it. Amazing, man. Yeah, this is the a focus that you all should maintain. Yeah, almost like many people. Good, well done. So here, what I will do, kubectl, right? Kubectl. That's an entry point, right? And then I can try to write same command, exec, execute, execute in a interactive mode, IT. We have already discussed. and which pod I would like to access. So I'll give my pod name. My pod name is what? Nginx hyphen pod. So whatsoever name that you have given. And then I would like to access it's basically like a cell. So sh I can try to give. Now I'm able to log in into that particular pod. I'm able to get into that particular pod. So ls, yes, I can see everything. If I would like to, create some file, execute some sort of a code, anything that I want, I can do it. I'm able to access the machine, right? I mean, like in my case, container, this case, container, I'm able to access it. I'm able to get into that machine. I can write Python code, I can execute it, I can, like, do whatsoever I want. Very, very simple. And for this specific machine, if I'm able to enter, I can, check the configuration, the resources, shared, everything I will be able to check it. So yes, even via kubectl, you will be able to access each and every individual machine, and you can control each and every individual machine as well, right? Each and every individual machine as well. So okay, let's say host name, nginx pod is a host name, ls is fine, and then let's do exit. So simple, kubectl execute. Let's, I mean, like, instead of docker, you just have to write kubectl and pod name. Rest is fine, rest is same as docker. So now let's not clear it. Yeah. Okay, so all of these things are fine. Now coming back to this one, anyone who is having doubt with this, what is the meaning of API version? What is the meaning of a kind over here? Anyone? Yeah. So kind is basically, it is going to define the type of the object that you are going to create. Metadata, I think it's fine. Spec is, I believe it's fine. The container, like, we are trying to create. So okay, can we write anything in place of API version? Yes, technically you can write your name as well. That can be treated as a version. It's better to write V1, V2, V3, V4 like that. Yes, how to write YAML scripting? By writing it. How to write means what? You have a keyboard, right? Start typing it. You will be able to write. The way I have written, I think I have written in front of all of you, right? So same manner you will have to write. You have to understand how to write Python code. I mean, no, that's not a question. That should not be a question. The way I have written, you have to write it. Okay, fine, guys. So now we are able to understand a basic. Fine, basic. Now, one more thing. So see, there is a nginx pod, and things are up and running inside a particular machine, inside a particular container. By the way, things are up and running. Now, I wanted to access nginx via my browser. So I'm a host, right? My window machine is host. Something is running in the container, and I'm able to tunnel it through a Kubernetes, by the way, right? kubectl. Through that, I'm able to, so kubectl or forget about kubectl. Kubernetes is technically orchestrating the entire pod, right? Orchestrating the entire pod. Now, if I have to access some service, or let's say Nginx is running in my system, so I have to basically access that Nginx via my local system, via my Chrome, right? Or maybe any other browser. So, how I will be able to access it? To access anything, you have to expose the port. Unless and until you are not exposing the port, you will not be able to access it. So, here, on which port this Nginx is running? On which port Nginx is running inside the container, within the small box pod? Port number 80, clearly mentioned. So basically what I have to do, so from this particular pod, I just have to expose this to the outer world and map it to any other port that wherever I wanted to access it. Okay, let's do it. Let's try to do a port forwarding over here. So to do a port forwarding, kubectl, and then here you can write port, and then you can try to write FORWARD, port forward. Okay, fine. And port forward of what you would like to do, of pod, which pod? So nginx, nginx hyphen pod, that's my name, right? Now do a port mapping. So on 5000 local, I would like to expose 80. Make sense? Yes, inside the container, I mean, like the Nginx service is running in my container managed by Kubernetes on 80, exposing it to the outer world, right? Now hit enter. So here forwarding from this to this, and then if I'll just go here and then if I'll type localhost, and let's say I'm typing like a 5000, I'm able to access it. Yes. So now I'm able to access it basically. So whatsoever services which is running, so if I have to like, so let's say instead of Nginx, I'm running my front end, my UI interface, right? My website basically I'm trying to run. So on some port, it must be serving inside the container. I just have to expose it. Yes, I just have to achieve it. Rohit is saying what it will achieve, sir. So basically, you are trying to expose the service to the outer world. That's it. Otherwise, how someone will be able to access your website? Think like this. This is basically a UI for Nginx. If I'm not going to forward it, I will not be able to access it. My users will not be able to access it. So that's the meaning of port forwarding. I think nothing new. We have done that multiple times, right? The same one. Okay, so now we know that how to create a pod, how to get into the pod, how to do a port forwarding, and across that, all those describe and logs and all those things we have seen. Okay, fine. Now let's say if I would like to delete the pod, right? If I would like to delete the pod, so how I will be able to delete the pod? So simple, delete command, kubctl, kubctl, and then delete command. Then write simple like pod. All those commands are like, in the similar manner. Give a pod name, nginx hyphen pod. So now pod is deleted, as you can see over here. Yes. So this is my standalone pod that I have created. And if you are going to delete the standalone pod, it will not be able to recreate it. Right? It was just a single pod that I had, and then I have deleted it. So it is not going to basically come back to the previous state. Okay. Now let's do one thing. So let's try to get into a situation so where I'm going to create a replica. So, for example, if Nginx is running, it should run not just on one single pod, but maybe in a multiple one, right? Let's try to get into that kind of a situation as well. So, I have to write another YAML file. So, let me copy this one for a reference. And then here, I'm going to name it as a replica.yaml YAML file. Just paste it for the base. Now, let's try to write all of these things with respect to the replica. So here API version, I can write, maybe someone has asked me, right? So can I write some different name? Okay, I'm going to give like a app slash v1. So I have written this, my name slash v1. That can also be possible. So here kind is what? So kind is basically replicacet, replica set, S capital. So replica set is the kind of the pod I'm going to create it. Meta information, so maybe I can try to keep it as nginx pod itself, or just to avoid the confusion, let me label it as a rs, replica set. Fine. Okay. Now, so here specs wise, I have to define the specs in this particular place. So I have to say that how many replica I want. So I want 3 replica, 5, 10, whatsoever I want, I can try to basically do it. Yeah. So I will be able to do it. And then here, so I can try to write something called as, so inside this specs itself, there is something called as selector. I'll explain you, selector. Yes. So selector. And then here, app colon nginx replica set, let's say pod, or maybe app I can define. Fine. And this one, so replica selector is done. Then there is something called as template. Metadata, labels I have already defined. So labels app ginx replica set app. Okay, rest is going to be same. I mean, like the base container is going to be same, so I'm just trying to use the same base container, and I'm trying to create a multiple replica for the same one. So there is nothing different that we are trying to, like, create it. So here we have given basically a selector. So selector is nothing but a key value metadata. Again, I'm trying to give, so that whenever I will have to filter out a pod, I will be able to filter out with the help of this nginx rs app. So this is just a label I have given just for the filtration. So again, it's a technically a meta information, right? It's a meta information that I'm trying to map it to. So match label, this is the label, and then inside the meta I'm matching that nginx this app. So whenever you are going to filter out, so out of thousands pod which is running, it will be able to filter out only that with this label, and you will be able to see whether it's running or what is going inside this. If I would like to log in, I can log in it. So this is just for the filtration, guys. This is just a tag, you can say, I'm giving to this one. Apart from that, even you can remove it. That's not an issue at all. But yeah, so, and as we'll progress, so we'll keep on like adding some of these things. The main thing that we have added over here is a replica. That's it, right? The main thing is a replica set, and kind is a replica set. That is something that we have done. Fine. Now, so let's go ahead and let's try to apply this particular pod configuration. Okay, so let me ping you this one. Fine, it's available inside your chat. Let's go here. So replica YAML is available. So kubectl, kubectl, and then apply, maybe forcefully apply it, and apply what? Replica dot YAML file. Creating, so replica set in version v1 cannot be handled as a replica set. Strict decoding error, unknown field specs container, unknown field specs replica. Okay. Replicas. It's a CAS, replicas. Fine. So specs replicas. I think this was the only issue. Replica set a strict decoder error. Unknown field. Field specs container. Unknown field specs containers also. Specs containers. Okay. So I have to manage one more specs to maintain this one. So SPC, fine. Specs this and specs this one, and this should come inside this one, guys. Inside this specs, there will be another specs. Use this one. This was the two error. I have fixed it. Hopefully it should run this time. So apply F this one. Replica set version v1 cannot be handled the replica set is recorder unknown field. Okay, spec dot spec. No, it should work. So template. There is an indentation issue, it seems. Let me keep it on third layer. Okay, done. So yeah, there was an indentation issue, and previously it was a S issue basically. So this is the final one, guys. You can try to use it. I have fixed it, and things are up and running. So here we are trying to run, but what I'm trying to show you is the replica, right? And I have also given a label so that we all can try to filter out. So here nginx rs has been created, right? With the help of this replica YAML file that we have. Now clean each and everything, and then let's try to check this entire things. So here kubectl and then get replica sets. So nginx rs desired is 3, 3 which I have desired, current is 3, ready is 3, age is 42 seconds, right? So fine, I'm able to get the replica sets. Then kubectl, again you can try to write even rs over here, same thing it is going to show you. Kubectl get, and then you can try to write all the old commands, get pods. So it is going to tell you that okay, fine, so nginx this, so nginx rs this pod, and this pod is up and running. Yeah. So up and running. Now what I will do, so as there are three pod up and running, and three pod is a part of replica, right? Three pod is technically a part of the replica. So I can try to call a delete pod like command. What is the delete pod command? Yes. What is the delete pod command? How I can delete it? Quick guys. Just now I have discussed 7 8 minutes back. You don't have to remember any command. When I say delete, it should be kubectl delete. When I say delete a pod, kubectl delete pod or the pod name. That's it. That should be the command. No need to remember anything. You don't have to mug up any of these commands. Simple. So what I will do, kubectl delete what? Pod. Which pod? So all of these three pods are the part of nginx rs, right? Which I have created. So what I will do, I'll try to delete this pod. I'm just trying to make sure basically that so things are running or not. When I'm trying to set my desired state is equal to 3, and even if I'm going to delete it, technically my current state will become 2, it is trying to spin a new pod automatically or not. Then only I can say that the entire like Kubernetes is able to handle this situation automatically. So here Kubernetes delete pod, and then this is the pod name, so I can try to copy one of this pod name and give it over here. So gpx4k, right? This is something which I'm going to delete it. gpx4k deleted. Now again I'm going to check. GPX4 is gone. See, this was gone, but instead of that, it has, can I say it has automatically created this one? It's not ready. It's like, container creating. Now, again, if I'm going to check, now it's running. Yes, now it's running. So 62 GMH. This is the new pod which is up and running. So likewise, I can try deleting, whatsoever I want. So maybe KJ9NX, second number, KJ9NX, I can try to delete. Deleted. Get pod. KJ9NX is gone. It has just executed the new one, right? 3 second back, just 3 second back, it has executed. So yes, the replica replacement that I was talking about, so it is technically working. My Kubernetes is trying to handle this replicas automatically. Make sense, guys? So yes, control manager is in action. So basically it is trying to check my desired state and a current state. It is trying to fulfill my desired state. That's it. That's where this control manager comes into picture. Yes, out of this architecture, this guy, this person is responsible for that, and yes, this person is in action. So yeah, fine everyone. So now I have three pods. Maybe I can show you my Docker as well here. So container image. So which image it is trying to use to find my hub. Okay, forget about this one. I'll leave it. I was just trying to show you image. Anyhow, image is inginx. Fine. Everything is running inside the Kubernetes. Yeah. Now, so yes, everything is running. Replica, I'm able to test. Is it this quick to happen in real time as well? It depends upon the infra etc. Yes, technically it is going to happen this quick, and because it is just going to replicate the same, right? Replicate the same. So with every time, like it is going to happen in the same manner. So get pod is fine now. So we are able to test all of this command. Now here, so I have given a label to the pod, right? So here I can try to write a command that kubectl get pods pod label app is equals to nginx hyphen rs hyphen app. So it is telling me that this is going to list down everything that I have inside this label. So app is equal to nginx rs app. It is trying to label down each and everything. I can even try to add a label from my end. That's possible, right? That's possible at any point of a time. Now So this is something that we are able to understand, this replica replacement. Now let's try to get into another situation. I'll copy the same, and then I will try to create maybe deployment.yaml, deployment YAML. Paste the same thing, and then we are going to modify one by one, one by one. So basically, the one now which I'm going to teach you is that how deployment manages a replica set and how deployment actually works at the end of the day. So here, if I'm looking for a replica management, if I'm looking for a rolling update means version change. For example, in Nginx, this version is working, maybe new update is coming. So obviously, I have to push those updates as well in my production, right? Roll back. So let's suppose if I have made some sort of a mistake, so how I will be able to roll back from that mistake. Scaling, self healing. So all of these things now we are going to see it inside my deployment. So here kind is equals to app v1, let's leave it as it is, deployment. Fine. Now metadata. So instead of this one, I'm going to write it down as a deployment. Deployment. Now replica is equals to 3. Let's try to keep it as it is. This match label, let me keep it as Nginx app itself. Template is going to be metadata label Nginx. Maybe I can try to keep it as a app over here. Yeah, rest is going to be same. Control S. Yeah. So now this is a basic config, same, almost same configuration, but with the kind is equal to deployment. I'm trying to use it. So let's try to use it, guys, this one, and then I'm going to show you how this is going to basically work. So here, what we can do, so we can try to write like a kubectl apply -f and then deployment.yaml file. Okay, so it's created. There is no issue at all in this particular deployment one. Now, here kubectl get deployments. So yes, Nginx deployment is running. So three of three, all three are available. Now get replica set. So my previous one is also running my replica set, and the deployment one which I have created. So this is also having a replica set. So it is trying to give me like, list of all the replica set that we already have. Now you can try to call describe, and then you will be able to like, maintain and manage, or you will be able to see what is happening inside the replica set. That's not a question. Now let's say a replica set is 3, which I have defined over here, right? Replica set is equals to 3, which I have defined in this particular place. From 3, I would like to make it 5. So let's say I'm getting like, a lot of traffic, or maybe I have to maintain the traffics, and I have to serve each and every one, and that's like a quick requirement that I have. Or maybe I have to create a more replica, that's a need that I have. So how I will be able to basically scale the replica from 3 to 5, or scale down even, right? To scale down. So to do that, basically you can write kubectl scale scale command. There is a command called as scale. Scale of what? Deployment. So it will be able to understand that I'm talking about this deployment set, right? And then inx the name that I have given, deployment. And here, so I can try to give a replica. Replica is equals to 5, let's say. Replica space. Replica, no, replica. Replicas. Yes, no space, replicas. CS, replicas. So now Nginx deployment is scaled. This is what it is trying to show. This is what it is trying to basically like, tell me, and maybe I can write kubectl gets pod. So here you will be able to see that it is having 3 replica, which was my previous one, right? It is having 3 replica. Now this one is having a 5 replica. So I'm able to spin two new pods 14-second before and 14-second before. You can see it over here. If I have to down it, so maybe I can write replica is equals to 2. I can again go and check. So now it became 2. If I have to make it maybe 7, so I can try to make it 7, and then I can go and check. So now it became 7. So this is how you will be able to create more replicas. You will be able to basically scale at any point of a time. So you can try to set it. So basically this approach, right, this approach is called as imperative approach. So there is two approach you will be able to find out. I mean, like, these are the English word. So there is something called as imperative approach. Imperative approach means from here, when things are up and running, so I'm trying to basically change something, right? So I'm trying to change it to 3 to 5, 3 to 7 to 2, and all those things. So this is called as imperative approach. Other approach is very simple. I can come over here and I can try to set 9. This is called as declarative approach. So I'm trying to declare it, and then I'm going to like apply it, and it is going to create that many number of the replica. So this is basically imperative and declarative approach. You can try to follow any of this approach. At the end of the day, you will be able to scale it. A command is there, so command is going to basically support you. Make sense, guys? Everyone? Yes. Okay. Now let's talk about a rolling update. Rolling update means, so as of now, what is a version of Nginx which I'm trying to run? What is the version of Nginx? 1.27, right? That's already available inside your YAML file. You can go and check. Yeah. So basically, here, what we can try to do. So let's say if we would like to upgrade it, right? So we would like to upgrade it from 1.27 to 1.28. So how I will be able to do that? So how I will be able to do a rolling upgradation in a version. For example, if there is a Python, I have to upgrade a Python across our entire pods or cluster that we have, or any version, right? So obviously every library will be having versions, and whenever new version comes, obviously we try to upgrade it. So to do that, I can try to again use a command kubectl kubectl set image, and then image of what? Deployment set, deployment deployment slash name of that. So nginx that I have given hyphen deployment, that's the name that I have given, and then nginx container. Let's go here. So nginx container, as simple as that, is equal to nginx 1.28. Fine. So here it should be set. Fine. So here, in this manner, what I'm trying to do, so I'm trying to update my container to a new version with nginx 1.28. So image updated. Very, very simple, right? Image updated. Now, image, it is telling me it's been updated. I would like to check the status. So cube ctl rollout status status of what? Deployment of what? Nginx hyphen deployment successfully rolled out. So successful rollout means like successfully it is able to update the version of nginx to nginx 1.27 to 1.28 basically. Kubectl get pods pods. So yeah, everywhere it is able to do the same thing. Now I can try to check rollout history as well. This is basically a status. So rollout history. So nginx deployment revision, nginx deployment, fine. Deployment revision 1, revision 2, changes cause none. I've just changed this one. So maybe because of that, it is showing me that one. Let me do one thing. Ready. Rollout history. So I just wanted to show you the worsening part here. So rollout history is fine. Revision changes cause none. Just a minute, guys. It should you must be able to see the version, but it is not showing. Hmm. So far, is it clear? Before this rollout, I'm going to show you rollout basically. Yes. So after rollout, I'm going to show you a rollback. But first of all, let me show you a rollout. Then only we can see the rollback. So whatsoever we have done, we are just going to revert it. Let me check what is a NGINX latest image which is available. GINX. Oh, 1.31 is available. Fine. Let me do one thing quickly because this has been done immediately, right? So let me change it to 29. Rollout history. Third version I have done. Rollout status. Yeah. So now this is what I was trying to show you that waiting for the deployment, Nginx deployment, rollout to finish 3 out of 7 new replica have been updated. So this is what I was trying to show you guys. So that has happened very quickly, right? I mean, just in a second. So I was not able to show you this particular one. By the time I have written this status command, so everything was done. So as you can see over here, so one by one, as we have a 7 pods. So 3 out of 7, then 4 out of 7, then 6 out of 7. uh, 2 replicas are pending termination. Okay, 6 out of 7. So all of these things it is able to roll out. This is something which I was trying to show you, the log, right? So that you will be able to get a sense that yes, we are rolling out the new update. Make sense? Yeah. I mean, the latest one is 1.31, so you can go ahead with that. Even you can go back. Okay. So now rollout is fine. We are able to basically do it. Uh, and suppose the new version which I have deployed, the 1.29 that I have deployed, right? So history wise, history. Fine. So 3 rollout we have done so far. So let's say the latest one 1.29 that I have deployed. So maybe because of that my system is crashing, and my system was working well with the previous one 1.28. Yeah, 1.28. So here what we can do, so we can try to roll back basically to the previous state. That is basically like a possible, and the command is very simple. So here rollout, and then instead of status I just have to write undo. It's like control Z. Simple. Yeah, control Z, that we type in our keyboard to get into a previous state. So here instead of status I just have to say that okay, so do a undo. Let me show you. So here nginx, and let's say I'm not writing a version, I'm writing invalid. Invalid. Now this is the wrong update which I'm sending. Invalid, I mean, it's not a version, right? Now it will try to roll out. So status 3 out of 7 new replica has been updated. So it is trying to, change the status. Let's wait for some time. And I have mentioned not a version, I have mentioned like invalid. So technically it is trying to pull this image, and I don't think that this image exists, by the way, with a tag invalid. So you can see that it is trying and it's taking a lot of time, and it will fail eventually. It simply means that I'm trying to basically roll out, right? I'm trying to roll out this new things with this image inginx invalid. Basically it will not, successfully update the images. So this deployment is basically a invalid deployment for me. And if it is an invalid deployment, because system will crash over here, so I can try to roll back. So it is taking more time because it's trying. So here, if you are going to type kubectl get pods, so it is going to tell you the three image which it is trying to update, right? So error image pull back off. After some time, so even like in this one, you will be able to see image pull back off. So it will try this inside all the pods that I have, which is like a running the deployment pod, which is up and running basically. And yeah, so this is basically wrong things. And again, so as you can see, it's a 0 0 0, means this one is not running, this one is not running, this one is not running. So basically the update which I have sent, so that has technically crashed my system. Yeah, this is what I was trying to show you. That update that I have sent, that is that has crashed my entire system. So it's basically 0. So if it has crashed some system, and if something is running inside that, people will not be able to access it. And because of my update, right, I have sent this update. So obviously I can try to roll back that particular update. So here what I can do, so I can try to basically instead of a status, like I said, history status, so I can try to basically type a command instead of a status, that rollout undo kubectl rollout undo, as simple as that. So now it is trying to roll back, and now if I'm going to execute the same command, get pods, so now everything is up and running. So whatsoever I have done now, that has been rectified, and now everything is up and running. So from 0 0 0 it came to 1 1 1. Everything is 1 1 1. I mean, like, the three that it was trying, right, so that has been removed, and then the other one is like as it is. At the end of the day, I was trying to maintain like a 7. Yeah, so that is there. So this is basically called as a rolling update, right? Rolling update. So here one more thing I would like to highlight, and you must have observed that uh, while it is trying to update this things, so it has created a new pod, and with the help of this new pod, it is trying to update it. At the same point of a time, my service was up and running in some other pods as well, as I have a replica. So my service is up and running. So basically, I was not out of service, right? I was not out of service at the end of the day. So this has to maintain basically the number of the pods which I have given. So yes, it is trying to maintain that particular part, plus one by one, it is trying to roll out, or maybe you can try to roll back from the another one. So hope this makes sense to all of us, guys. Any question? Anyone? Yes. So Sasank is asking, can we scale up NGINX pod just like we do it for a deployment? Scale up, yes, yeah. We have done that, right? So you can just set the number in an imperative manner, or maybe you can try to go and you can try to basically inside your YAML file itself, you can try to set the number, and it will be able to scale up. Are not we make this whole process automated? Yes, we are going to do this whole process automated, and that is going to happen by tomorrow itself. So when I will be talking about IAC, infrastructure as a code, where I'll be talking about Terraform, and you will be able to automate everything. Don't have to do anything, by the way. So yes, people are like, it's not like, if I have 1,000 machine, I just go configure things, each and everything by myself. Obviously I try to control it with the help of code, and so whatsoever is written in my code, it will happen. As simple as that. Make sense, guys? Can we do a scale up and scale down kind of auto scaling here? Yes, you can do it for sure, no doubt at all. So again, I have seen some question: which specs are used by this component, control panel component, and where uh, to define which specs are used by these component? Which component? So here we have four component: API server. Everyone is having its own responsibility. ETCD, scheduler, control manager. So which component? Okay, so now let's try to understand a couple of more things from this one. Okay, so let me show you a load balancer over here. So load balancer we have already seen with respect to a NGINX, right? And we all understand the definition of load balancer. We have also done a practical. So let me copy this itself, and then here load balancer dot YAML. Fine. So now let's try to talk about a load balancer a little bit. So here the load balancer is going to be a kind is going to be service. Now app v1 is completely fine. NGINX, I can write it down as a load balancer. And then spec replica, I can try to remove it. I don't want a replica. I just want one endpoint, and then SPEC spec selector Nginx app, fine, and then so not required. And then here's a spec. Here container is fine, spec is fine. We can try to write a port number. Inside a spec, fine. Let me write it down here. Second label, yeah, ports. Now inside this port, so let's say we can write ports ports port 80, and then we can try to write target port 80. Okay, so here we can define a type is going to be load balancer. So this is basically a service I'm trying to create, so basically which is going to help me out in terms of doing a load balancing at the end of the day. So again, with the help of this service type, I can try to manage, maintain a node IP address, cluster IP addresses, load balancer, all of those things. I will be able to manage it. So I can go and I can try to run this one, and then it is going to work as a load balancer for me. Let me do one thing. So let me create one, full scale application, and let me show you in that one. Maybe that is going to make more sense. So let me, you can execute this service one, load balancer one, if you want. So let me ping you this. I mean, like, just you have to like open up Kubernetes and then apply. Okay. Now, so what we can do, so let's try to create one Python application. So here we can try to create maybe like, app.py file. And inside that, so let's say, there is a code which has been written and there is a API which has been exposed. So code wise, it's a simple like things which has been written over here. So at home, it is going to return this message, hello from Kubernetes, host name, socket name, all those things. And when you are going to call health, it is going to return you this one. So there are only two endpoints. One is a home endpoint, route endpoint, and then one is a this endpoint which has been created. It is going to run on 8000 port number wherever I'm going to run it. So internally, let's say on a container. So just create a app.py file quickly, and then here let's create a requirement.txt file. requirements requirement.txt file quickly, guys. Inside that, so let's say I'm going to keep like a Flask and Gunicon. Yeah, so keep a Flask and Gunicon. And then there is a Docker file, which is a custom one. Docker file we can try to create. Now inside this Docker file, I think we have written so many Docker files, so I think we all will be able to understand. So this is my Docker file. So I don't think that anyone in the class will not be able to understand this file. So simple. This is the image. This is basically a directory. Inside that, it is going to copy requirement.txt, install it, and then copy by app.py file from local to container, expose port 8000, and run the application, the Flask application that we have. And we have two endpoints. So this is how I will be able to spin the Docker. Okay. So this is my like a Docker image. My Docker image, by the way. So far I have been using nginx, but here, so I'm trying to create my own custom Docker image out of this Python one, so that I will be able to run my own custom application. So each and everything is done. Let's close it. Now, how I will be able to manage with the help of this Kubernetes, right? How I will be able to manage this entire things with the help of Kubernetes? That's a main question. So shall we go ahead, guys? Shall we try to do it? Have you copied all this three file? See, I'm not trying to explain you this one or maybe like this one. I'm just trying to explain you that, let's say I have a file, and I think we all understands the API part, right? We have two endpoints. One is a home and one is a health. So, and then we have created a Docker file, which we have done like even in my last class, basically. So I'm going to run something in a Docker, but I have to control this Docker file with the help of Kubernetes. So far, we have done like we have basically like using a Kubernetes, but our image was nginx, which I was trying to download from a Docker hub. But here, so I'm trying to build my own custom image as well with my own custom requirement. So here, when we have own custom requirement and when we have to basically like build this entire things, so let's say how we are going to basically build this entire things at any point of a time. So for example, if I have to build this Docker file, how I will be able to build it? What is the command? If I have to build this Docker file, so what is the command? So can I say that I can simply call, let's say there is a ls, we have a Docker file over here, so we can try to call simple Docker build. So docker build, build, same command, right? So hyphen t, and then I can try to give a name Euron uh, k8. Let's say I have given a name app, and then v1. This is the tag which I have given. So v1. The Docker is not recognized as a name of CMD. Is it? Docker is not available. Okay, spelling mistake. Docker, right? I was surprised. Error docker build x build requires one argument, help for more information. So docker file, I think because of my YAML, it is restricting it. Hmm. Okay. Mm, no, there is a dot. Okay, let's build it. So yeah, it will take some time. It will build my image. Hmm. Docker build done. So now if I'll go here inside my Docker image, what is my image? K8 app, this B1, right? This is the app which I have built. And then if I want, so I can try to run it. So command for running something is like run command. So clear Docker run. So run what? So maybe in a RM mode, I'm doing a port forwarding as well. So if something is running inside, I would like to access outside as well. So outside 5000 port number, inside I have already given 8000 port number for Flask app. And then I can give like image name. So Euron, I can copy it from here. That'll be better. Yeah. So just copy this one, this image name. So I'm going to execute this particular image. Fine. Now, so everything will be up and running. I can go here and I can check my container must be up and running now. So, okay, this container is up and running. So if I have to access something from my local, so I will be able to access it with the help of localhost 5000. Execute. Still, it is taking this one. Yeah. So now I'm able to see my own message. Hello from Kubernetes. This is the message which I have written inside my app.py file. Hello from Kubernetes on a home, right? If I'm going to call health, so it is going to basically show me health. So status is basically healthy. Okay, fine. So there is my own like a Python code, and yes, I am able to basically access it with the help of Docker. That we have already done. So nothing new for us, by the way. How I will be able to manage and maintain it with the help of Kubernetes, that's a question. That's something that we are trying will try to solve it. So let me do one thing. So let me do control C. I'm going to stop the container. So now there won't be any kind of a container up and running. It's gone. Everything is clean. Now here I will go and then I'll try to create another YAML file. And let's say I'm going to like name it as a Python deployment.yaml file. Now I can try to write all of those configuration which I have written so far. So basically like with respect to a deployment, by the way. So here, let's say I'm going to pick one of my template deployment.yaml. Same thing I'm going to pick, guys, by the way, and I'm going to copy it inside Python deployment. And now let's start changing this things. Let's start modifying some of these things. So instead of nginx, Python app deployment. Okay, replica is equal to 3. Leave it as it is. Match label selector, and here so I can write instead of nginx, let's say I'm writing Python app template metadata label, and then here also Python app. Okay, now specs wise, so here I have to make some sort of a changes. Now name wise, so let's say I'm going to write it down Python app container, just a name, Python app container. Now here image wise, so what is a image name I should give? How it will be able to execute my Python thing? Yes. So how it will be able to execute my Python Docker? So far what we have done. So we were trying to write this image name, and it was trying to search this image in my local and then on a Docker hub. Now, can I say that I have already built my image? My image is available. This image, right? This is the image. So this is the name. So simply you have to copy and you have to basically paste this particular name. Nothing else you have to do. So this is my image name. So obviously it will try to search for this particular image, and this image I have already built, which is my own custom image, by the way. right? So own custom image, by the way. And then container port was what? 8000. Something is running at 8000 internally. Externally, I can try to use a port forwarding of a Kubernetes to access it, by the way. So now I'm trying to control my Docker image, the custom one which I have created with the help of Kubernetes. Make sense, guys? So I've not done much of changes, by the way. I'm like simple a name change. The major change is basically my image change, the custom image that I have built. That's it, right? So likewise, I can try to build any number of images, and then now I'm trying to run it as a three pod, so replica. So whatsoever power that Kubernetes gives you, you will be able to get all the power with your custom app as well. As simple as that. So okay, save it. Go inside the terminal, ls. So here Python deployment and then YAML file that we have. So simple kubectl apply. Apply what? So forcefully apply uh, Python deployment YAML file. Okay, enter, created. So now basically, like, it must be up and running. So kubectl get deployments. So yeah, Python app deployment, it is still deploying. It's not like done so far. Zero. It's my custom image, right? So basically it will try to, like, install the requirement.txt file, then it will try to run it, it will try to expose it. So 0 of 3, 0 of 3, get pod. So yeah, for this one, okay, so error in image pull, guys. So this is the error which I have received. It is not able to pull, so it will never be able to deploy it. So my deployment has technically failed. Okay, so let me go and check what is the issue. So K8's app, that's the same thing which I have copied. So I think my name is correct. Name is Python app container. Image is, yeah. So yeah, image name is fine. So here there is another tag which we can write. Mm, 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 mm. Image pull policy. Image pull policy if not CLT present. Port is equals to fine. Container port. Okay. So if not present, if not, I should be capital. Get pods. Image pull back off. I think it was for the previous one. So the previous one is not running. Again, image pull. Uh, But it should not give me this issue, by the way, because I have given a correct name of my image. Euron Kids app. Yeah, that's a same name of the Kids app. Yeah, it should run actually. Even in my system, it should run. I mean, like it's just a image name, right? So technically, it will try to search for image in a local or maybe in a hub or something. So yes, it should work actually. Just image that I have given over here, and it is telling me that it is not able to pull that particular image. So it is not able to pull it from a Docker. Mm, That's a thing. Image pull back off. So again, failed. Let me check what could be the possible issue because I'm able to see the images. So technically, it should work. Anyone who is able to execute it, I think Manoj, yeah, for Mrityunjay it's running, for Manoj also running, for me it's not running. Strange. Because I am not able to find out any other error by the way. They also it's running. Yes, let me try. So let me copy this name Python app deployment, right? Let me delete it. So simple kubectl delete kubectl delete and then deployment and delete this one. Okay, so now it must be gone. Fine. Now let me rerun deployment apply f python. Fine. Get paths creating. Okay. Again, error in image pull. So it still is not running. I have deleted and I have again restarted, but error image pull. Very strange. Although my name is same and I have image over here. Image pull policy if not present. So I mean, fine. Policy doesn't matters here. By the way, if it is able to find something in local, it should give me this one. Inside a cluster. So let me remove this one. Eh, Okay, let me make it as a never. Last try. Any VR never. So it will be able to pull it from the Docker because it's out of Kubernetes cluster. Okay. Get pods. Let me delete it first. Even in case of a never, it is giving me same issue. Mm, mm, mm. Ideally, this should work. If not present, should work. Delete the deployment and then apply it and then check get pods creating. Fine. Fine, guys. Maybe I'll have to restart my system because there is no issue at all. I mean, even you can see, right? And many of you are able to execute it. So basically, it should work, but maybe because of some XYZ things, cache or something, you can say it is not working as of now. But yeah, it will work with the same command, as simple as that, and you all will be able to access it. In many people's system, I think it's working for Dev, for Manoj, and for Mityunjay. Everyone, it's working. So it will work, and there is no issue with anything. By the way, I can see everything is correct syntactically and even execution wise. Okay, so that's all about Kubernetes, everyone. Hope all of you are able to now understand, and all of you are able to get a very very good sense and a connects basically with respect to a Kubernetes. Yeah, so I can't restart, right? Otherwise, I have to terminate your classes. I can't restart my system. So that's a current problem that I have. Okay, so that's cool. I hope all of us are able to understand this entire like Kubernetes, and we all will be able to use it. Simple, right? If we are able to understand, at the end of the day, you just have to connect all the dots and just remember this. And if you are going to remember this, done, right? Command wise, syntax wise, I mean, Docker, Kubernetes, it's very very similar, right? It's just like a Linux command, I would say. That's the reason, so I have started my entire op session with respect to a Linux, because at the end of the day, you are dealing with that system only inside a container or even inside the Kubernetes. Now tomorrow I'll be talking about basically Terraform. So infrastructure as a code, EAC, basically. So where you are going to write everything inside a code, you are going to use basically a framework called as Terraform, and with the help of that, so you will be able to control, you will be able to manage, maintain automatically each and everything in all the environments, and even the scale and security and testing, everything you will be able to implement it. So EAC, basically infrastructure as a code. So I have one question. Yes, can we use AI things in cluster for monitoring the pod? Obviously you can use it. See, it's not a AI. At the end of the day, your system will be up and running in some physical machine, right? Now with the help of even like Prometheus, Grafana, and there are a lot of CloudWatch. There are a lot of things which is out there, and which is going to help you out in terms of getting a logs. Now once you have a log, so yes, there is a Prometheus, Grafana by which you will be able to see a very good graphs and everything with respect to a resource utilization and everything. But yeah, So if you would like to apply some sort of analytics, some sort of AI on top of that, you just need a log. So this is where AI will come into picture. It's not like AI will be doing something on a infra level. AI, you can supply a logs to that, and then based on that, if you're going to create a different kind of a agent for security, maybe for health checkup, it will keep on reporting you. It will keep on, like, it's kind of a wrapper. Look, at the end of the day, everything will be running on that local machine, and sorry, on those, like, metals basically on those plates. And on top of that, you can try to install maybe Kubernetes, generate a logs, and then try to present it with the help of AI. This is where AI comes into picture. Analytics agent we can create on top of KIT. See, you are getting a log. Now it's your take. Very simple. And then you can try to loop it back as well. So let's say you are getting some sort of an instruction that there is a some vulnerability, some security, you should not allow this, you should not allow that, and that too in a dynamic mode. So yes, your agent will try to give an instruction again via YARC, you can say, infrastructure as a code. At the end of the day, you have to execute some sort of a command. So your agent will be executing it. That's it. Yeah. So this is where your AI layer will come into picture. Apart from that, nothing. Interesting session for the day. Thank you so much. Kubernetes is a very important chapter, very important concept. See, guys, if you have to understand ops, right? I simply tell anyone that try to understand a Linux command, understand your GitHub, right? Then try to understand basically, a little bit of AWS, Azure, and GCP major services, like 20 25 services across this entire infrastructure management, log management, security management, and then Docker, Kubernetes, Terraform, monitoring, logging. End of the story. Because wherever you are going to touch anything in our ops side, that's the only thing you will be able to encounter. And across that, yes, in a market there are so many other tools which is available. I mean, like, hundreds and hundreds of tools are available. You can try to build your own tool as well if you have a thought, because now you don't have to write a code. You can just use a Claude, and then you can, like, build your own tool and start selling it. This is what other people have done. But the baseline is same. Everything is running on a Linux machine, and on top of that, so we are just trying to build the wrapper to control the things. Please share this document with us. This is a image, by the way. Yeah, this is an image. So I have already like posted this image inside a Euron channel. So maybe I'll try to post it there. Yeah, or maybe you can take a snapshot of this now itself. It will be better, right? I think this is visible. Take a snapshot, everyone. Fine. Okay, so fine, everyone. Thank you so much. Take care. See you again tomorrow with the new class, new chapter, our Terraform that we are going to discuss. Thank you so much, everyone.